Okay, so we're starting 4.3 objective today, 4.3a. 4.3 is all about refining our ability to find zeros and using multiplicity to make our graphs look a little bit closer to what they should look like. So we'll be using multiplicity to test you on your graphing skills or your sketching skills. Okay, so today's topic, multiplicity of zeros and writing polynomials. And we practiced a little bit writing polynomials already. We practiced finding a. Okay, we practiced using zeros and points. So we're going to continue that practice hopefully today. You're a little more efficient. Our objective, you can use given conditions like degrees, zeros, multiplicity, and points to write and graph polynomials. So here's the notes. Today, I'm going to be nice. You can write your polynomials in factored form. You don't have to convert them to general form. Okay? Factored form of a polynomial, and I'm going to include multiplicity in this definition. So A, the all-important, ever-important A, always must find it, times x minus c raised to some multiplicity. It might be 2, 3, 4, times x minus another c, but we'll make that a d. And I'm just going to raise it to the nth power because we don't know if they're the same. And then that, of course, continues depending on the degree or how many zeros that we have. And this is factored form with zeros. But here's what I want to say. And if you're going to listen to if you're going to ignore me today, do not ignore me right now. All right? You always have to find A. Because A is a really powerful number in a polynomial. It tells you if your graph opens up or down. It tells you what your end behaviors do, right? It tells you how stretched out or how compressed your graph is. So you always have to find A. So be on the lookout for that. Okay. It's powerful. If you don't, you're going to get it wrong. I forgot what I wanted to say there, so it might come back to me. We might add a little bit to that in a second. Okay. If you don't, you're going to get a C or a D or an F on the test. So clue in and ask good questions when you have them. So I will do one example and then you will practice, and then don't let me forget to pause the video whenever I'm having you practice, and then when I start teaching again to press play. Okay, or record. Here we go. All right, so find a polynomial f of x of degree 3 that has the indicated zeros and satisfies the given condition. Write f of x in factored form. So here's what we already know. Let's unpack that. We know, I'm going to go with my pencil right now. Degree 3, that's helpful. Zeros. I'm going to color code, which is why I'm rewriting my zeros. My first zero, I'll do in red, -1. My second zero, I'm going to do in blue. And my third zero, I will do in green. Just this one time, I'm color coding. Okay? So we know our zeros. Now, since there's 3 zeros and it's a degree of 3, do any of my zeros have multiplicity? No, they don't. So there's no multiplicity on those. They're all to the first power. So that means my graph's not going to flatten out anywhere if I were to graph it. Okay, let's grab up one other piece of information, and I'll do that in purple. I have this information. What does this information give me? An x and a y. But do I know what A is? I don't. So I have to use all I can to try to figure out what A is. So I'm going to call -2 my x and 80 my f of x. Okay, so I'm going to plan out my equation now. I'm going to pick up my pencil. And I'm going to plan out the format of my equation, how many zeros, all of that. So here's what I'm planning. F of x is equal to a, always, times x minus c, times x minus d, tell me when I can quit, times x minus e, times, yes, I can keep going? I have to quit because I only have 3 zeros. And they're all different. Okay, so there we go. So that's my plan. So I'm sticking with my pencil one more time. And anything that I'm not substituting in, I'm just going to write with my pencil. So I'm not substituting a because I don't know what it is. So I'm going to do my parentheses with my minus signs in them. And so basically I'm telling you right now, I'm substituting all those other variables for numbers, which means I can solve for a, right? Because it's the only unknown. So I'll pick up my purple pencil first, and I'll go ahead and insert my x's and my f of x. My f of x is 80. Notice that I didn't write the f of 80. I saw a couple people do that the other day on the quiz. And they'd plug the x in properly where it was supposed to go, but then they try to solve for x and they didn't know what to do because they'd written f of 80. So they had to stop the problem. It's a strange thing. I hope you weren't one to do it, but if you did, just stop doing that. Okay, so I'm going to plug in all my x's. So inserting -2, substitution. And then I'm going to pick up my red pen real quick, and I'm going to insert my -1. And I think right now I'll go ahead and change that. That's a double negative. So that's supposed to be +1. And then I'm going to grab my blue pen and substitute in my 2 for D. And then my green pen and substitute in my 3 for E. And that's it for color coding. I'm done. No more color coding for me. You can color code if you want to continue to do that. Now let's simplify and solve for A because we have to find it. So 80 is equal to A times -1 times -4 times -5. Give you a little time to process because I hear you still dropping pens. I just simplified those numbers. Now let's multiply it out. So A, let's do -1 times -4 times -5. I believe that's -20. A. So we're solving for A. So we'll divide both sides by -20. So 80 divided by -20 is -4. All right. So I found it. The all critical A. So now I can go ahead and write my polynomial. So I'm going to go back in and put my f of x and my x's back in the equation because polynomials have to have x's. But I'm going to insert my 4 and keep my zeros. So here's our solution. F of x is equal to -4 times x plus 1, right? That's my first zero, times x minus 2 times x minus 3. And I just went back and gathered that stuff up from step 2 right here. +1 minus 2 minus 3. And that is how you find A. And write your polynomial. And you don't have to multiply it out. You can leave it in factored form. Okay, so you try, and when you're done, press pause, and when you're done, you can come back and see if your work is right. Okay, so when you're done, your A was -3. And so you plug in the -3 in all of your zeros, and then, of course, simplify. I'm going to just point out that one of my zeros was actually 0, so I put it in the front position so that I could write it with the A term. That's the proper place to put that 0. Okay, and so you get -3x times x plus 4 times x minus 3. Any questions? All right, then we are moving on to example 2. A little more complicated. Okay, so let's read the problem and unpack it. So it says find a polynomial f of x with the given conditions and write f of x in factored form. So A, we have a polynomial with a degree 6. And 0 and 3 are both zeros of multiplicity 3. That tells me something different. And the f of 2 is -24. P.S. Sketch the graph. Okay, so let's unpack that. That's a degree of 6. So that tells me that my end behaviors are same end behaviors because it's even. So it'll both either go up or it'll go down because you're raising a number to an even power. So they'll either both be positive or they'll both be negative based upon your A term. Okay, we don't know A. A equals, I don't know. Okay, here are my zeros. I only have 2, right? My zeros are 0 and 3, and I don't want to write a plus sign there. 0 and 3. And I need to address the fact that they have multiplicity. So 0 has a multiplicity of 3, which means I'm raising it to the third power. And this 0, 3 has a multiplicity of 3. So that means that when I do my graph, the graph is going to pass through that 0, but it's going to get flat near the 0, like I showed you a little bit earlier. And we have a point here, and our point is to negative 24. So that's our x and our f of x. And I guess I'll just call 0 my c and 3 my d. So I'm going to plan out my equation. So f of x is equal to, I don't know what a is, but I do know I'm doing x minus c cubed because it's got a multiplicity of 3, and x minus d cubed. And that covers my degree of 6. Okay, so my conditions are set, my plan is set. Now I'm just inserting my values. So f of x is negative 24. I don't know what a is. My x is 2. My first 0 is 0 cubed. And x is 2. And my second 0 is 3 cubed. So we'll simplify that and we'll solve for a because we always have to find a. A times, well, that's 2 cubed. If you don't mind, I'm just going to do an intermediate 2 right there. So that's 8, right? And then 2 minus 3, just a little intermediate negative 1 right there. And negative 1 cubed is negative 1. So that's negative 24 equals negative 8a. So we're going to divide both sides by negative 8. So a equals 3. So now I know what my a is. And that tells me that on my graph, since it's positive and it's got same end behaviors, that both sides of my graph should go up. Let's write our equation. That's the first thing, find the polynomial. So f of x equals 3 times x minus 0 cubed times x minus 3 cubed, keeping the zeros in there. Can I simplify anything? Yeah, I should probably write that as 3x cubed times x minus 3 cubed. So a little intermediate step in there if you didn't catch on that one of your x's was, or one of your zeros was a 0, which is this indicator right here. Okay, so now we have to sketch the graph. So probably a sign diagram would be very helpful in this situation. So let's take our factored form here, 3x cubed and x minus 3 cubed, and create our sign diagram. We have 2 zeros, one at 0 and one at 3. So we'll plot those 2 zeros on our graph or our sign diagram. And then we'll think, okay, so if I plug in a negative 1, that's 3 times negative 1 cubed, which is negative 3. So negative on the left. If I plug in a positive 1, that's 3 times 1 cubed, which is 3 times 1, which is positive. So, you know, it's just like if it were a linear term. To the left is negative, to the right is positive. It's an odd degree here. Okay, and then same thing with this one. To the left is negative, to the right is positive. So let's see what's happening on the left end of our graph. We are heading to positive infinity. Between them, we are below the graph. And on the other end, we are above. But let's just identify that this are flat. Flattened. Because they're both multiplicity of 3. Both of them. So our graph will be steep and then get to the zeros and kind of flatten out. And then they'll get steep again. All right, and let's see, do we have a y-intercept or do we already know what our y-intercept is? Yes, we do. Look, is a 0. If 0 is one of your zeros, it's also your y-intercept. right? It's a function. It can't have two y-intercepts. All right. So there's our x-axis. And we don't need to put a scale on our y-axis because we're sketching. But we're refining our sketching skills. Before, in 4.1, we just sketch above and below and we'd make curves. But now we're flattening out near our zeros. So sometimes I like to do my little flattening out parts first. That's not very good. I'm going to try that again. Sometimes I like to get them in there. That's how it goes. It's coming from positive infinity, flattening out once we get close to 0, flattening out until we get to 1, and then it gets really steep. But then on the other side of 3, we have to be above again. So we have to come back up. And then as we get, don't go straight up because that's vertical. This is a function. Having trouble with my pen here. Flatten out. So your graph's going to do something like that. And you remember that graph I showed you at the beginning of the period? That was that one. Remember it did that. So, and it actually goes down pretty low. So there you have it. Now you do one. You try B. So press pause, try it out, and then press play and see if you got it right. Okay, so your f of x, your equation was x plus 5 squared times x minus 2 squared. Your graph is always positive unless it's at 0. And we did tuck in the y-intercept in there by plugging in 0 for x. We got 0 plus 5 squared, so 25 times 4 is 100. So we just tag that on your graph. Doesn't have to be perfect, but I do want to see y-intercepts. Whenever you don't have a 0 that's 0, find your y-intercept. Okay, plug in 0 for x, you find your y-intercept. Doesn't have to be drawn to scale, just tack it up there on your y-axis. Okay. Last one. What? You have a back. Notice at the bottom it doesn't say summary on back because I wasn't done. Okay. So example 3. Ooh, we have to hurry. Holy moly, we have to hurry. Okay. So find a polynomial f of x with given conditions. Write f of x in factored form. It says the third degree polynomial is shown. So it's telling you your degree. However, I can already tell that it's my degree because it has how many zeros? 1, 2, 3. And do you see any flattening out near any of those zeros? No. So that means each 0 has a multiplicity. It doesn't have a multiplicity. It's a 1 because there's no flattening. So it's definitely 3 zeros, so degree of 3 in that situation. Our zeros are shown, right? So we have a 0 at -1, 0. There's 1 marked for us at 1.5, 0, and 3, 0. Here's what I don't know. I don't know A. And I don't have enough information yet to write my equation. I need one other thing, and that is another point. In this case, they're giving us the y-intercept, which is nice, but let's just go ahead and label that as our x and our f of x. So basically, it's like saying, all right, so my f of 0 equals 3.5. So we're trying to satisfy that condition. We definitely want to make sure our graph is passing through there. So do we have enough information? Here's our plan. So here's my plan. I'm going to do f of x is equal to a times x minus c times x minus d times x minus e. You with me? Okay. So that's my plan. Now I'm just going to go and plug all my information in. So my f of x is 3.5. My a is what I'm looking for. X is 0. My first 0 is -1, so minus -1 is +1. And 0 minus 1.5. And 0 minus 3. So we'll go ahead now and simplify that. So 3.5 equals a times 1 times -1.5 times -3. I think 3 times 1.5 is 4.5. So 3.5 equals 4.5a. We're going to divide both sides by 4.5. Now, here's the thing. I'm not going to accept that as the simplified form of that fraction. So here's what you do. This is the tenths place. I don't want any places. So I'm going to multiply both sides, numerator and denominator, by 10, and that gives me 35/45. It's just like we change all fractions. And then we can simplify it to 7/9. And there's our A. So now we can do what we were asked to do. Write your equation. F of x equals 7/9 times x plus 1 times x minus 1.5 times x minus 3. Okay, now you guys still have one to do. I'm pressing pause on the video. Of course, when you go home, you'll have to check to make sure it's right. And don't forget to write a summary. So with plugging in all the values that you got from your graph, you should have gotten A equals -1. Noticing that your 0 here at 1, 0 had a multiplicity of 2 because the graph bounced off the 0 instead of passing through. And then you plug it into the equation. And the final version should be negative x minus 1 quantity squared times x minus 3. Homework for tonight is 4.3a. It is 2 through 6 even, 7, 10, 12, and 14.